All right, so the problem says that we are looking for a line through the origin, so y equals mx, so that it divides the region bounded by this parabola and the x-axis into two regions with equal area. And we want to find out what the slope is. Okay, so first of all, I noticed that this thing right here, if I set it equal to 0, because I find the x-intercepts, I factor out of 3x, I've got 0 equals 3x times 1 minus 2x. So this tells me that either x equals 0, or this factor right here equaling 0 tells me that x equals 1/2. So the graph of this thing, it's a parabola opening downward because of that minus sign. It goes through 0, it goes through 1/2, and it's opening downward. Okay, so we're looking for this area. Well, we're going to need this area because what we're going to do is we're then going to cut that area in half by this line here that's going to go through the origin and go like that, so that the area above the red line is going to be equal to the area below the red line there. So yeah, how do we do this? Well, the first thing I want to do is I want to figure out how much total area there is so that I know how much half of it is. So first thing is just to integrate from 0 to 1/2 of this 3x minus 6x squared dx. And I'm going to just do that on my calculator. So it is equal to 0.125, which actually is equal to 1/8. So half of that area is going to be 1/16. Okay. So now I'm going to do another integral, which is just either the top half or the bottom half. Now I look at this and I say, if I did the bottom half, the top function is piecewise because sometimes it's that line and sometimes it's that parabola. Yet if I do the upper region here, I always have the parabola on the top and I have the line on the bottom. So I got to find that point of intersection so that I know over what x values to integrate here. So to find that point of intersection, I've got to set, why am I doing weird things? 3x minus 6x squared has got to equal mx. So I'm looking for an x value that makes the same y value in both of those. So now, solve for x. So I'm going to subtract the mx over to the other side. So I've got 3x minus 6x squared minus mx equals 0. I'm going to factor an x out of that thing. So x times 3 minus 6x minus m equals 0. So this tells me that either x equals 0, which I knew was that point right there, or 3 minus 6x minus m equals 0. If I solve this for x, so add the m over here, subtract the 3. Actually, it might be easier just to add the 6x over there. So let's write it this way. 3 minus m equals 6x, and then divide by 6. So x equals 3 minus m divided by 6. Okay. So the intersection point right here is 3 minus m divided by 6. So now what I'm going to do is I'm going to take the area in between those two, so top minus bottom. So I'll look at the integral from 0 to this thing, 3 minus m over 6. The top function is the parabola, 3x minus 6x squared, and then subtract off the bottom function, which is the line, y equals mx. That's the height function times a little bit of width for an area, and then add up all those areas to get the area between the two curves. This now, because this isn't just a number here, it's got a variable in it. I can't just type it into my calculator. But I know what I want the output to be. I want the output to be half of 1/8, so that would be 1/16. So if I do this integral, I've got 3x squared over 2 minus 6x cubed over 3 minus mx squared over 2. Evaluate that between 0 and 3 minus m over 6, and we want that to equal 1 over 16. So let's see what we get here. 3 times 3 minus m over 6 squared over 2 minus 6 times 3 minus m over 6 cubed over 3 minus m times 3 minus 6, sorry, 3 minus m over 6 squared over 2 minus what I get when I plug a 0 in. But when I plug a 0 in, this will be 0, that'll be 0, that'll be 0, you add them all up, you get 0. Right? And that has to equal 1/16. All right, now I've got to solve for m, and this is a cubic equation in m. Let me just try a few things and see if I get something to work here. Anyway, I think I can. There's a 3 minus m squared here, and there's a denominator. You got a 36, but that cancels with a 3 to leave a 12, and then you divide that by 2, so that 2's down there with the 12, so it's a 24. All right. This one, the 36 cancels. No, sorry. There's 6 cubed, and it cancels with the 6, leaving a 6 squared. But then there's an extra 3 down in the denominator. So I've got 36 times 3, which is 108. And that's got a 3 minus m cubed right there. And then here I've got a 36 in the denominator, because that's a 6 squared, and then another 2. That's a 72. There's an m times 3 minus m squared. And this has to equal 1/16. All right. These both have 3 minus m squared, so I'm going to get a common denominator and combine those two fractions. So I'm going to get a common denominator, I'm going to multiply this one top and bottom by 3. Right? So I'll have a 72 in the bottom. This one is a 3 times 3 minus m squared, and then I've got a minus m times 3 minus m squared. And then I still have a 3 minus m cubed over 108. This is equal to 16. And actually, this is kind of nice, because the 3 minus m squared cancels out, leaving another 3 minus m. So this is actually 3 minus m cubed over 72. And this is 3 minus m cubed over 108. And this is equal to, sorry, 1 over 16. I don't know why. I don't know how that became a 16. It should be a 1 over 16. I can factor out a 3 minus m cubed now. And I'm left with 1 over 72 minus 1 over 108 has to equal 1 over 16. I could do that, I suppose, or I could just say divide by that. So I've got 3 minus m cubed equals 1/16 divided by 72 minus 108. I'm going to go to my calculator here and do that. So this is 27 over 2 when you simplify that whole thing. Actually, what I did is I just typed this into my calculator and it told me 13.5. And so that's 13.5, which would be 27 halves. So anyway, that's where I got that from. And so I'm trying to solve for m, so I can take the cube root of both sides. So 3 minus m is the cubed root of 27 over 2. And actually 27 is a perfect cube. That's 3 times 3 times 3. So this would be 3 over the cubed root of 2. And then solve for m. So actually I'm going to add the m and then subtract this. So m equals 3 minus 3 over 2, sorry, the cubed root of 2. Okay. And if I type that into my calculator, 3 minus 3 divided by 2 raised to the 1/3 power. And I get 0.618898. Anyway, I think that's the answer. One thing that I'm going to double check with myself here is that, where did we start here? Come on now. Where do we start? If I could find the slope of the line right here, I know that my answer has to be less than that. It's probably not half, but anyway, at least I know less than that. So if I look at y equals 3 minus 6x squared and I take the derivative, let me get way down back to the bottom here. Wow, that was a lot of work. If I look at y equals 3x minus 6x squared and I take the derivative, that would be 3 minus 12 x, and I plug a 0 in, it's 3. Because we plug a 0 in, you get 3. I'm surprised by this answer, but anyway, it's correct. I'm only surprised because I drew the picture very badly wrong. Really? Yeah, okay. So anyway, this is less than 3, so I'm feeling okay. I'm going to pause for a moment. So there's the slope of the line that cuts the area in half.